Okay, let's talk about this is the final thing, I think. The storage cost between Postgres and MySQL. So B+Tree secondary index values, and I talked about secondary indexes versus a primary index difference. It's very important to know this difference, is the difference between the two, right? And can either point directly to the tuple, this is an example of Postgres, or to the primary key. And this is one of the reasons that Uber moved from Postgres to MySQL. So hey, Postgres points directly to tuple. As a result, write amplifications implode. And I have a write amplification lecture. Go to the section where you have like a various database discussion. You're gonna see the write amplification. Very critical to understand that, right? So if you have a secondary index and this secondary index points to the tuple, then the tuple size is really not that large, right? Because it's a fit. I believe it's a 32-bit. I might be wrong. It might be 64-bit, but that is the pointer. While the MySQL secondary indexes point to the primary key. So if the primary key is large, if it's an integer, you don't have a problem really. It's just tiny, right? But if it's a GUID or a UUID, that is a really bad idea to put a GUID or a UUID as the primary key in AnyDB MySQL, because any secondary key unfortunately will point to the primary key, and plus the whole thing is clustered, so inserts are so slow because of the randomness of the UUID. It's just not worth it at all. Okay, so as a result, the secondary indexes will be so large because they have all these values that points to primary keys, which are effectively UUIDs, which are these large things, right? And you can do all sorts of tricks to convert UUID into, instead of using a string, which is I forgot what's the string of the UUID, but so many bytes, right? 128, I believe. But you can trick it to use like 64 bytes or less than that, using the binary representation of UUID. But still, it is still large, right? If it's large, it takes space, can't fit in memory, right? Your memory is precious. You might say, I'm going to add 1 terabyte worth of memory for my primary database. Sure, but do you have to? Right? Think about this, right? Scaling and the database engineering is not something that you take lightly. You have to think about all this stuff, and it all makes sense when you understand these basic fundamentals. That is what I want to convey in this lecture. The B-trees are not something you do math on. Every decision you make costs you, right? And it's important to understand how these different DBMSs make these design choices, because every design choice can lead to a completely different outcome. If the primary key data type is expensive, this can cause bloat in all the secondary indexes, as I talked about. Leaf nodes in MySQL AnyDB contains the full row, since it's an index organized table or a clustered index too. So that's another thing, right? Clustered indexes in general. SQL Server also have this idea of clustered indexes, clustered index or clustered tables. Sometimes they call it index organized table. So this is this is an index where the index is the table itself. If you think about it, it's just the whole thing. The leaf node has the whole row and all the columns in it, right? So that everything is really clustered nicely. It has disadvantages and advantages, right? I'm just not gonna go through it, but it's very important to understand it.